You know, from the operating system running on your computer right now to the software that flies rockets to Mars, there's this incredibly powerful unseen language that acts as the backbone for pretty much our entire digital world. That language is C++. And today, we're going to dig into how it was born, how it's changed over the years, and why it's still so unbelievably important. So, to really get why C++ even exists, you've got to travel back with me to the 1970s. Programmers back then were facing this huge dilemma. They had to make a really tough choice. Did they want their code to be incredibly fast, or did they want it to be clean and well-structured? The problem was, they just couldn't have both. And this choice, this fundamental problem, it basically split the programming world right down the middle, creating two different camps, each with some pretty serious downsides. Okay, so on one side, you had languages like Simula. It was fantastic for organizing these huge, complex projects, but man, was it slow, painfully slow. Then on the other side, you had C, the undisputed king of speed. But as projects built in C got bigger and bigger, the code would often just devolve into this tangled, unreadable mess that programmers call spaghetti code. You were basically stuck choosing between a turtle and a plate of spaghetti. Not great options. This is where the story gets good. One programmer looked at this whole situation, at this impossible choice, and thought, you know what? Instead of picking a side, I'm just going to forge a whole new tool that does both. And that programmer was Bjarne Stroustrup. He was a Danish computer scientist working at the legendary AT&T Bell Labs way back in 1979. And he gave himself a very clear mission: create a language that could finally solve this speed versus structure problem once and for all. His goal was just so elegant and simple. He wasn't trying to reinvent the wheel here. He decided to just take the best of both worlds. That amazing organizational structure from Simula, which was built around something called classes, and fuse it directly with the raw, down-to-the-metal speed of C. And that's exactly what he called it at first: C with classes. I mean, it's a very descriptive, very humble name, right? It wasn't until a few years later, in '83, that it got its much cleverer name, C++, which is a little inside joke for C programmers. It's a nod to the increment operator, basically signifying that this was the next step up from C. But here's the thing. Creating the language was really just the beginning. C++ didn't just pop into existence fully formed. Oh no. It has been constantly evolving for over 40 decades now, adapting to meet the insane demands of new technology. You can kind of break its life down into three big chapters. First, you've got the early years, where the core DNA of the language was established. Then came the standardization era, which is where C++ really grew up and became this official, stable language with a massive toolkit. And then finally, we have the era we're in now, modern C++, which has been nothing short of a revolution for the language. Yeah, this modern era is what made C++ feel brand new again. Starting around 2011, there was this massive shift in the community's focus. The new goal became making the language safer and way easier to use, all without sacrificing even a tiny bit of its legendary performance. The C++ 11 update was a total game changer. It gave us features like auto, which basically tells the compiler, hey, you're smart, you figure out what kind of data this is, saving developers a ton of time. It added lambda expressions, a super clean way to write small functions right where you need them. And maybe most importantly, it gave us smart pointers, this amazing tool that automatically manages memory for you, preventing a whole category of really nasty bugs and crashes. And the evolution didn't stop there. Not by a long shot. The C++ 20 standard brought even more firepower. We got concepts, which act like guardrails to make sure your code is used correctly. We got modules, which completely changed how big projects are built, making compile times way faster. And we got coroutines, which introduced a much simpler way to write code that does a ton of things at once, like handling thousands of network connections. All right, so we have this tool. It was born from a very specific problem, and it's been sharpened and refined for over 40 years. But what has it actually built? Where do we see all this power in action? Well, the answer is pretty simple. You'll find C++ anywhere and everywhere. The performance isn't just a nice-to-have, it's a strict requirement. When being fast is absolutely non-negotiable, that's when developers reach for C++. Just think about the foundational software you use every single day, the very core of your operating system. Windows, Mac OS, even parts of Android. It needs C++ to talk directly to the hardware. When you're blown away by the graphics in a video game running on the Unreal Engine, you're looking at C++ in action, where every single millisecond counts. Even in a field like AI, when you're using a tool like TensorFlow in Python, all the intense, heavy-duty math is actually handed off to a super-fast C++ engine running in the background. From financial trading systems where microseconds can mean millions of dollars to SpaceX rockets where reliability is literally a matter of life and death, C++ is the invisible engine making it all happen. So when you pull all of this together, from its philosophical beginnings to its modern-day applications, you start to see the clear and really powerful legacy of this language.
And this, right here, is the most important thing to remember. C++ was never meant to be just another programming language on the pile. No, it was designed from day one to be an engineering tool for building massive, robust, complex, high-performance systems. It lets you manage that complexity without ever sacrificing speed. And that right there is why it's still the gold standard for building the world's digital infrastructure.
Which kind of leads us with one last thought. Knowing that C++ is the engine behind everything from the most creative video games to the most critical system software on the planet. If you were going to dive in, which of those two paths would you find more fascinating?